Hello everyone. So today in this lecture we are going to study one of the variant of tree, that is binary search tree. Tree is one of the non-linear data structure. As you know that non-linear data structure follows the parent-child relationship, and binary search tree is one of the variant of tree. So first of all, what is binary search tree? A binary search tree is one kind of a binary tree which is either empty or in which each node contains a key that satisfies the following conditions, right? So what are those conditions? So the first condition, that all the keys should be distinct, right? That means that should not be common keys, right? Then the another condition, that for every node X in the tree, the values of that particular key in its left subtree should be smaller or lesser than the key value in the X. That means if you are having a left child of X, so that value, suppose my X is equal to 20, right? So the left child should be lesser than 20, not greater than, right? Similar way, for every right child, the value should be greater than. That means if I am having X that is 20, the right child should be greater than. That means suppose we are having, this is one of the example, right? So here you can see this 56, right? So 56 is my root node. As you can see that the entire left subtree, right, is having the values, key values that are lesser than your element, right? So lesser than 56, right? And all the values in the right subtree, that is having the value that is greater than your 56, right? So here you can see that 26 is lesser than 56. Yes, that's true, right? Similar way, if I consider this 26, then the left child of 26, that is having the lesser value, that means 18, right? Here 18 is having lesser value, right? Similar way, 12 is having lesser than 18. Now if I consider this 18, the right child of 18, that is a 24, right? So that is having the greater value than the 18, right? But it should be lesser than this 26. Why? Because if I consider this 26, this 24 falls on the left side of 26, right? So that is that should be a smaller, lesser value, right? So that you should keep in mind, right, that if we consider any node X, so the left child or a left subtree, the values of all the nodes should be lesser than the X value of X, right? And for the right, it should be greater. Now, how to create binary search tree, right? So this is the construction of BST, right? So suppose I have given this sequence, right? So this sequence is having DBLFHAN, right? So this is alphabetical order, right? Alphabetical sequence, right? It is not compulsory that you have been given alphabetical number, like it can be numeric numbers as well, right? You can given like some numbers as well, right? So here in alphabetical, first we need to follow the alphabetical order, right? So here we have D, right? So the first node I have created, that is D, right? Then the second thing, that is B, right? So when we insert B, we need to check whether B comes before D or after D. So in alphabets, B comes before D, right? So B and D, right? So that means we can say that the value of B is lesser than the value of D, right? So here that's why this B will become the left child of D, right? Now the next element is L, right? So if we add L here, L is greater than D, that means I have added it in a right child. This is your right and this is your left, right? So B will be on the left side, left child of D, and L should be on the right side, that is right child of D, right? Now if I insert F, next element is F. If I insert F, right? So F is greater than D, because we have like A, B, C, D, E, F, right? So D and then we have F, right? So it should be greater than D, but it is lesser than L, right? So it should be greater than D, that means we should add in this portion, right? And it is lesser than L, that means first we need to go right and then we need to create the left one. So F will become the left child of L. Now next, if I want to add H, right? So we need to start from the root only, right? So here D, right? So after D we have H, right? Then we need to check for the L, right? So H become before L we have H, right? Then we need to check for the F, right? So after F we have H, right? So we need to add the H over here, right? So I hope you understood this, right? So next element is A, right? So A, as you know, that is the very first element of the alphabet, right? So it should be lesser than D as well as lesser than B, right? So it should be the left child of B, right? Then if I add N, right, so you can check it out, right, that it is greater than D, it is greater than L, right, so it should be the right child of N, right. So this is my final tree, right. So this is my binary search tree, BST, right. Now there are traversers, right, we for traversing purpose, like we are having this tree, right. So in this tree we have the traverser, right. There are 3 types of traverser, right, Inorder, Preorder and a Postorder, right. So let me write it over here, that is Inorder, Preorder and Postorder. These traversers are used for the traversing purpose if you want to search for any particular key, or if I want to add some new thing, right. So that's why we need to first of all traverse the entire list, right. So for the traversing purpose we have 3 options: Inorder, Preorder and a Postorder. In order, what we do, we go for the left first, right. Then we visit that particular node and then we go for the right one. So I can simply write it, that is LVR. LVR stands for left, visit and a right. Similar way, for a preorder, we need to, as the name suggests, preorder, pre means what? First, right? So we need to first visit it, then we need to go for the left and then we need to go for the right. So it is like VLR. And for the post order, as its name suggests, post, that means last. So we need to visit the last, so it's LRV. So L, R and V, right. Now how to find the traverser sequence, right. So suppose I am having this graph, this tree, binary search tree, right, and if I want to find the Inorder sequence, right. So you can do it directly, but this is the first time you are learning this, so I am writing it out. So for Inorder we have LVR, so I am just writing LVR over all the nodes Okay. Now we need to start from the root node, right. So root node is, this is my root node, right. So first what we need to do, we need to go for the left. So the left of D, that is B, right. So this left I am just cancelling out and I am traversing towards the left, right. Then what I am having, B, like, but again I need to traverse towards left, right. Again I am traversing, right. Here I am having A, right. Now if I have A, is there any left child of A? No, there is no child of A, right. So that means we can consider that's a null, right. So here L, the left side is null. So what we need to do, we need to visit, right. So we need to visit A. So I am just writing my Inorder sequence. So first we have A, right. Then check whether the right is available. No, that's not available, right. So we just cut it out and go back, right. Here L is already done. So what we need to do, we need to visit, right. So we are visiting this. So we have this B, right. Then we need to go for the right one, but the right is not available, right. It's null. So I'm just cancelling it out, right. Again backtrack. So what we have, that's a D. Left is done for the D. Visit is still remaining. So we have this D, right. Then where we need to go? Towards the right, right. So it's a R. Then here we come over here, right. That's LVR, right. For left, for L we need to go towards left, right. So we are going towards here. Then for F, left, but as you know that here nothing is there, right. So that means I am just cancelling out L, right. Then what we need to do, we need to visit, right, visit F. So I need to add F to my list, right. Then we need to go to the right side. So like I'll just cancel it out, then that's a H, right. Now here L is not there because it's a leaf node, right? Then we need to visit it, so H is over here, then R is not there, so backtrack, right? If I go towards L, L, V, R all are done, so go back. Now we need to visit L, so L, right? Now we need to traverse towards R, right? So right side, if I go towards right side, L, left is not there, we need to visit N, so N, and then right is not there. Right. Now, as you can see, all the nodes are already visited. That means that's the end of my traversal, right? So, after the end, what I get my in order sequence, that is A, B, D, F, H, L, N. And as you can see, it's in alphabetical order, ascending order, alphabetical ascending order, right? So, whenever if you have a binary search tree, BST, so in order of binary search tree will always alphabetical order, right? Just keep in mind that's a trick, right? Now, if we go for the pre-order, the same way we need to do it, but instead of LVR, what we need to use? VLR, right? So, I am just writing the pre-order sequence. You can do it by step as I show you here, but for this I am just writing the answer, right? So, if I go for the pre-order, right? So, first what we need to do? We need to visit, right? So, here we have D, right? So, D, then B, then A, right, because it's like VLR. So, first we need to visit D, right. So, we have visited D, then again we go for the L part, right, VL. So, we need to go towards the left, right. Then again what we need to do? We need to visit, right. So, visit, that's a B, then again what we need to do? We need to go towards the left one, right. So, then A, then L, V, L, R. So, visit A, then left is null, right is null. So, we need to go back, right. Here if we have VLR, right. So, V is visited, already done, left is already done. So, we need to go towards the right, but right is null, right. So, go back. Here V and L are already done. So, we need to go towards the right one, right. So, then we need to visit, that is L, right, because VLR first we need to visit now, because it's a pre-order, right. So, L is done, then we need to go towards the left, then we have this F, right. So, VLR, so first we need to visit, so we have F, right. Then we need to go towards the left is not available. So, we need to go towards the right, so that we have H, right. So, if you go towards the F, again VLR, right. So, first we need to visit, that's H, right. Then left is not available, right is not available. So, go back, right. Here VLR all are done, go back VLR. So, we need to go towards the right, right. So, if you go towards the right, then there is N, right. So, first we need to visit N, right. Then we need to go towards the left is null, we need to go towards the right is null, right. So, that means that's N, because all the vertexes are, all the nodes are visited, right. So, this is my pre-order sequence, that is D, B, A, L, F, H, N. Similar way you can do it for the post order. I am just writing the answer for the post order. So, what we will get for the post order, that is A, B, H, F, N, L, and D, right. This is the answer for the post order, right. I have just written the answer, right. If you want to do it, you can just follow this shortcuts, right. LRV, right. First we need to go towards the left, then we need to go towards the right, and lastly we need to visit it, right. So, that means the root node. Just keep in mind, if you have a binary search tree or any tree, in a post order sequence, the root node should be at the last one, right. And in a pre-order sequence, the root node should be the very first node, right. So, yeah, that's all. I hope you understood this, right. So, this is a traversal. So, what we have studied in this lecture, that what is binary search tree, right, how to create binary search tree, how to add the things, and how to traverse the binary search tree. In that we have 3 methods: in order, pre-order, post-order, LVR, VLR and LRV, right. So, that's all for today. Thank you.